Okay, so starting from yesterday, there is no bow tie. I know. Do I need to go get a bow tie? Wow, that was really quick. It's outrageous. Okay. All right. This is my mirror, my camera that I'm gonna have to do it in. It's still hard to see. You made a mask. That's nice. What's it look like? Email me a picture. I'll bring it up on stream. There'll be free advertising for you. How's that look? It's kind of dark. It's kind of hard to tell. Let me open up some light here. Better? Yeah, utan na image said. Want to see the pic. Want to see the mask. Fantastic. Sorry to let you guys down there for a second. That makes me feel better because no one else today mentioned it. So I just thought, okay, fine, the kids don't care about the bow ties, but I can see that it's important to you all. And I appreciate that. All right. No sound. Are you sure? Can anyone else hear me? For me, it shows that there is sound. Can you guys hear me or no? You can hear. Okay. Megan, I don't know. You're busted. Finley. Okay. I'll bring that up at the end. Cool? Cool. All right. So, starting off with the hyperbola, we have our center at 1, 1. Okay. From there, we have that a squared is 36, which means that a is 6. Now I need to decide, so this will determine my vertices. Since x is the first term, then that means this is going to open to the left and to the right. Okay, so my vertices will go to the left 6, 1, 2, 3, 4, 5, 6, and left 6, 1, 2, 3, 4, 5, 6. So from the center, 1, -5, -5, 1, and 1 plus 5, so 6, 1. So that means b squared is 4. So b is 2. So I'll go up 2 and down 2 from the center. 1, 2, 1, 2. So these are my co-vertices. So 1, 3, and 1, -1. My two co-vertices. And this will give us the outline for our box, right? So this almost looks like it could be a hyperbola, or sorry, an ellipse, right? If I just kind of drew the ellipse part, but this is, I know that it's not because I see this minus sign here. So that informs me that this is a hyperbola. So I'm going to use this to draw the box. Well, what the heck? Okay. So that helps us because then we can draw those diagonal lines that go from corner to corner and are supposed to go through the center. Mine didn't exactly. And then the last thing we need is the foci. So we know c squared is a squared plus b squared. So c squared is 36 plus 4. So c is the square root of 40. We can simplify that radical. Square root of 40 we can think of as square root of 4 times square root of 10. Square root of 4 is 2, so 2 root 10. Which means our foci, now remember the foci should be on the same side that the hyperbola is opening towards, so that means left and right. So 1 plus or minus 2 root 10 for those foci. And now to actually graph them, 1 minus 2 root 10. So it'd be about negative 5.3. And then 1 plus 2 root 10. 7.32. Okay, so there's all my foci, and then I can just actually draw the hyperbola. So there we go. I've been missing a lot here. What are... Megan's tanning on her roof right now. She sent me a Snapchat, says Cassidy. Tanning during math class, just a normal Tuesday, says Ted Bundy fan 23. It's so nice, says Megan. My laptop might overheat, but that doesn't matter. Great. Well, Megan, that's kind of sad. I don't know how well you can see this screen, but I totally readjusted the colors of my markers. I don't know if you can tell. See, I added this orange color over here. I also went in and altered this to make it a bolder pink. And same thing for this kind of periwinkle color. It's bolder, can see better. Orange complements the pink well. Yes, of course. All right, so totally rejuvenated it for you. Looks like my notes. Great. Great. Okay. So there's my hyperbola. Again, kind of involved drawing, has a lot going on, but not crazy bad. Copyrighted. Okay, so let's go on to kind of the similar types of problems that we've done with other conic sections. So for example, instead of starting with an equation and trying to write out what the graph or draw what the graph is, let's start backwards and have some vertices and work to figure out what would the equation of the hyperbola be. So my first thing for these types of problems is I like to draw myself a little sketch so that I can more easily determine what the heck is going on. Okay, so -1, 2, and -1, -2. Okay, so if these are my two vertices, and then it tells me also my foci, -1, +3, and -1, -3, okay? So I can tell then that since the foci is on top and bottom and the vertices are on top and bottom of one another, so this graph is going to open up and down. It also tells me that the center should be right in between here, this red dot. All right, so I should be able to immediately determine my center is -1, 0. Okay? The equation I'm thinking of should be this setup. And it should have the y variable first, because again, we know that this, from this sketch, I can already tell that this is opening up and down. So that y variable should be first in the first term. I've already figured out what h and k are, the center. So now I just need to figure out what is A and what is B. So just from looking here to here, from the vertex to the center, I can tell by looking at my points, right, that distance is 2. Right, or from here to here, that distance is 2. Well, remember, that then represents what A is, right? From the center to the vertices is a distance of 2. So A is 2, which means A squared is 4. Okay, so I've now figured out what A squared should be. So I know H, I know K, I know A squared. Now I just need to figure out what is B squared. Well, B is the distance between the center and the co-vertices. So I don't actually know what the co-vertices are, right? The co-vertices are like green dots over here somewhere, but we don't know those. It doesn't tell us. Okay, but we can figure out using the foci. Okay, because from the center to either one of the foci should be C. Okay, so just looking at our point values, right, the y value from the foci, 3 or negative 3 to 0. So on either side, that distance is 3. Right, so C is 3, which means C squared is 9. So now I can use my equation that I know that C squared equals A squared plus B squared. C squared I know is 9. A squared I know is 4. So plus B squared. And then solving this, I would just subtract 4. So I get that B squared is 5. And I don't even need to write now that B is square root of 5, because again, in the actual equation for a hyperbola, that denominator is just B squared. So I can just put 5 down there. So I have everything I need. Notice that the K value of the center is 0. So I would put y minus 0 squared, but y minus 0 squared, I don't really need to write that. That's kind of redundant. So I'm just going to write y squared over a squared, which we figured out is 4. So y squared over 4 minus, because there's always the minus in the middle of a hyperbola, not y, x minus h, so negative 1, so x plus 1 squared over b squared is 5 equals 1. So this is that hyperbola, the equation of this hyperbola. It has these particular vertices and these particular foci. One time Mr. Conklin said to me, "Megan, with how organized and pretty your notes are, I would think you would be able to pass the PFA." Big shout out to Mr. Conklin. Hilarious. Well done, Mr. Conklin. What PFA was it? Was it math? I mean, he has a good point. You know, you would think you'd have it under control. Any PFA. True. Conklin just throwing down straight facts here. All right, so lastly, just like we've done before, let's practice putting from general form into standard form. You would think with non-existence notes I wouldn't pass any PFAs. You would think. Okay, so as a reminder for our steps, we're always going to want to first take our, whatever it is, our constant, and move it to the other side. On the left side, I'm also going to group x terms and group y terms together. So 36x squared plus 72x minus 4y squared plus 32 equals negative 116. We can't complete the square just yet. So with ellipses or with hyperbolas, or I guess potentially with parabolas as well, we have these coefficients on the quadratic terms. So I first want to factor those out before I actually do the completing the square. Oops, I forgot my y here. Okay, so for the x's, I'm going to factor out 36. So x squared plus 2x, and I'll leave space to complete the square. Factor out negative 4 from the y's, so y squared minus 8y, and I'll leave some space to complete the square, equals negative 116. Let's add b over 2 squared. So 2 over 2 is 1, 1 squared is 1. So plus 1. But what that means on the right side is I'm not just adding 1. I'm adding 1 times 36. Because there's that coefficient of 36, I have to imagine if I distributed that, I'm actually adding 36 to the left side. So I need to add 36 to the right side as well, not just 1. Okay, negative 8 over 2 is negative 4. Negative 4 squared is plus 16. But I'm not just adding 16 to the left side. Right? This 4 would get distributed. So I'm actually adding negative 4 times 16 to the right side. X squared plus 2x plus 1 factors into x plus 1 squared. Y squared minus 8y plus 16 factors into y minus 4 squared. On the right side, let's do some calculations. Negative 116 plus 36. Equals negative 144. And then I need that right side to be 1. So how can I make that 1? Well, I'll just divide everything by negative 144. Now it's just simplifying fractions on the left. 36 over 144, or negative 144. So that would simplify into negative 1/4. Negative 4 over negative 144. So that would simplify into 1 over 36. And then I'm just going to do a slight touch up here in that we always want the minus sign to be in the middle. So I'm just going to swap these two terms. And there we go. So this is the standard form of the hyperbola. I could now determine exactly, looking at this immediately, I can tell since the y is in the first term that this will open up and down for this hyperbola. Right, a squared 36, b squared 4, center at negative 1, positive 4, etc. We could fully graph from here or figure out the foci or whatever it is we need to do, figuring out using those pieces.